Hello everyone and welcome back to our renewable energy series. In this video I will be talking about ocean thermal energy. Energy is available from the ocean, can be in different ways, can be utilized in different ways, either using the energy uh, from the ocean, the heat energy from the ocean, or using the tidal energy from the ocean, or using the wave energy. So today I'll be talking about the heat engine or the heat that can be extracted from the ocean. So the ocean can act as a heat engine. There can be a 20 degrees difference between ocean surface temperature and the temperature below 1 kilometer. The surface acts as a heat source and the deep cold water acts as a heat sink. So the temperature difference can also be steady. In Florida or Hawaii and other Pacific islands, the, it's suitable for the advantage of this idea because the circumstances they allow the extraction of the heat. So this extraction is basically called ocean thermal energy conversion or OTEC. So there are two types of heat engines, of ocean heat engines. The first one is closed cycle system. In closed cycle system, the working fluid is basically ammonia. So heat from warm seawater causes the fluid, like ammonia, to be evaporated in an evaporator. When it's evaporated, it expands and rotates the turbine and therefore produces electricity from the generator, which is connected to the turbine. The cold seawater is brought up and cools the ammonia vapor in the condenser, and this liquid returns to the evaporator and the process repeats. The other type is called open cycle system, where the working fluid is the seawater. The warm seawater is brought up into a partial vacuum, basically to lower its pressure and therefore easily can be evaporated. In the vacuum, the seawater boils and the steam drives the turbine, and therefore it generates electricity. The steam enters a condenser where it is cooled by cold seawater brought up from very far below the sea or the ocean, and it condenses back into liquid as it discharges into the ocean. Boiling water in a vacuum. Why would we boil water in the vacuum how I just mentioned? The boiling point of any liquid depends on the temperature and pressure. So when you put the liquid in a vacuum, you lower its pressure a lot. So when you do so, you can boil it with a relatively lower temperature. So boiling process occurs when the molecules in the liquid have enough energy to break free from the surrounding. And if you reduce the pressure, you reduce that amount of energy needed. In OTECs, we depend mainly on the concept of Carnot cycle, and the Carnot efficiency is very low. It's about 7%. And even when we put it into practical, um, the efficiency will go lower to about 2.5%. So this low efficiency requires a lot of water, and to produce 100 megawatt, you would need basically 25 250,000 liters per second of warm water and cold water. For a 40 megawatt plant, a 10-meter wide intake pipe or a 10-meter diameter pipe is needed to supply a 40 megawatt plant. This is an example of an OTEC in Hawaii. This is how it looks like. So the other uses of OTEC, it can generate hydrogen for use as a clean fuel source. It can generate fertilizer from biological nutrients that are drawn up from the ocean. Ocean water drawn up can be also used as a drinking water using distillation process. Thank you everyone for watching, and hopefully you have learned something about this form of energy.